Hello friends, this is Jim here, Science Talk, and have a study that appeared in the journal Nature Geoscience. The lead author and principal investigator is Tapio Schneider, who is an environmental scientist at JPL. And basically this study looked at what unprecedented rise in carbon could do to clouds. Now, this is an interesting one. And basically what they're getting at is saying that the carbon rise could cause a tipping point as far as cloud formation. So, if CO2 concentrations in the atmosphere become high enough, the clouds that shade and cool, some say the tropical, subtropical oceans and land masses, could become unstable and disperse. That would allow more radiation to reach the surface, causing surface temperatures to increase, be it land or water. And that increase could be as high as 8 degrees C above the levels for most of human history. Now, I just did a video talking about the PETM, Paleocene-Eocene thermal maximum, some 56 million years or so ago, where CO2 levels were really high, and temperatures were about 8 degrees higher than they are on average than they are now, and that humans are on track to get to those very high levels 56 million years ago. And that's so you could sort of consider this is a study independent of the other one I talked about, but they kind of go together when you think about it. Now, why would the clouds disperse? Well, primarily as you're increasing the temperatures, the dew point is going up, is also increasing. So the clouds are less likely to form in the first place. And the other thing you have to keep in mind is, yes, we're burning all these greenhouse gases. We're releasing CO2, methane, nitrous oxide. Also, another product is water vapor. When you take an alkane, the general formula is C sub n H sub 2n plus 2, right? No parentheses over the end, just 2n plus 2. That's your general, what we call a saturated hydrocarbon. Nothing but carbons and hydrogens. All the carbons are single bonded to each other. That's a typical alkane. Octane is an alkane. Octane means there are 8 carbons. When you take an alkane and you combust it in the presence of oxygen, the products are CO2 and water. It's not just CO2. You get water. Look at a tailpipe. What do you see dripping off the edge there? That's water. That's from burning fossil fuel. So we're also adding water vapor. We're warming the air. The air can therefore hold more water vapor. And water vapor is, you guessed it, a greenhouse gas. So there's that other dynamic aspect to this whole situation. Now, what their researchers are contending is that this dramatic increase would be independent of any warming directly linked to human activities, i.e. the steady rise in CO2 emissions themselves. So the researchers now say they know a bit more about the climate mechanisms by which global warming could accelerate. Now, a lot of this is based on models and other calculations. So bear that in mind as I share with you some of the methodology that they did. If carbon dioxide ratios climb to 1,200 parts per million, now we're not there yet. That would basically, in essence, being 3 times the approximate current levels. Without drastic action, this could happen in the next century. Now, we know in the past, I did a video where I discussed CO2 levels throughout Earth history. We know in the past that the CO2 levels could easily be that high, and it's been much higher in the past, far distant past. But the point is, this is not an unreasonable level. Earth has seen these levels before in the past. So if this were to happen, hitting 1200 ppm, Earth could reach a tipping point, and the the marine stratus clouds that shade 1/5 of the low latitude ocean, tropics, subtropics, and reflect between 30 and 60% of shortwave radiation back into space could break up and scatter. Now, they specify shortwave radiation. Let me explain that a little bit. Sunlight energy comes in the UV wavelength, right? That's why if you go bathing, if you go sunbathing, you put some sunscreen that has various properties to block out the UV radiation, because too much exposure to UV radiation is not very good. So the sunlight energy comes in the shortwave range, the UV range, and then it reflects back out into space in the long wave, the infrared range, because there's some absorption and scattering of the molecules, the photon energy, etc. So clouds would reflect, the top of the clouds would reflect some of the UV back into space. No clouds, UV, that sun energy goes all the way to the surface, starts warming up the surface. That's basically what's going on. So the best way to remember it is UV in, IR out. Pretty much a quick, dirty summary of it. So, Dr. Schneider states that I think and hope that technological changes will slow carbon emissions so that we do not actually reach such high CO2 concentrations. But our results show there are dangerous climate change thresholds that we have been unaware of. The role of clouds in the intricate interplay of sunlight, forests, oceans, rocks, and atmosphere that controls the planet's climate has been the subject of argument. Scientists are still trying to get a handle on this, so these are all active areas of research. Do clouds really slow warming? If so, by how much and under what conditions? These are some of the questions. These are what we test when the experimental designs are set up. And as you would expect, there's no simple answer. Okay. So, Professor Schneider, in an attempt to resolve what he calls a blind spot in climate modeling, i.e. the role of clouds, he and his colleague worked on small-scale computer simulation of one representative section of the atmosphere above the subtropical ocean, and then used supercomputers to model the cloud and the turbulent movement over a mathematical representation of the sea, and then they started to tune up the atmospheric concentrations of CO2, and that's where they came up with the result that once CO2 levels reach 1,200 parts per million, the stratocumulus clouds vanish, did not reappear until CO2 levels dropped to well below that level. So this research may illuminate what happened during the PETM, when all that Arctic ice melted and so on. But back then, 56 million years ago, what was the source for the carbon? We don't know. So the role of clouds, and basically clouds are water vapor. So the role of water is a very difficult thing to model in the climate models. Scientists are getting better at it. It reminds me of an old joke. If you ever watch some of the original Star Trek episodes, the original series, and the Enterprise is coming into orbit around the planet, and there you see the planet, the beautiful continents, and the oceans, and so on, and you don't see any clouds in the sky. And the joke was, because clouds are difficult to model. So anyway, but this is some interesting research, and it's kind of a warning. Thank you for your time. Hey friends, this is Jim reminding you to subscribe and share my videos. Also, don't forget to click the bell so that you know when I drop a video in. And I'm also asking for you to please support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your continued support.